Okay guys, what you see here is probably good information to write down. We'll go over again what we talked about in class. It says in the right triangle there are actually 6 possible trig ratios or functions. A Greek letter such as theta or pi or phi, actually not pi but phi, is used to represent an angle. Okay, so here we have the sine, which is really S-I-N-E, but we write S-I-N, the 3-letter representations. We know this. Opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. The reciprocal functions, which that's the title, the reciprocal functions of each one of these for cotangent is adjacent over opposite. For secant is hypotenuse over adjacent, and cosecant is hypotenuse over opposite. And so you can tell these here. And so the idea is basically that some of these are actually useful. It helps you be able to determine if you're going to have to multiply once you do your trig ratio or if you're going to have to divide. And so these are the 3-letter representations. And it says, notice that the 3 new ratios are at the right are the reciprocals on the left. A reciprocal means you flipped a fraction. Notice that these are all reciprocals, right? And so that's why they call them reciprocal functions. Another way to look at it is sine is, cosecant is 1 over sine. And secant here is 1 over cosine. And tangent is, cotangent is 1 over tangent. So whenever you see 1 over anything, that's mathematically representing the inverse. Okay, that's mathematically representing an inverse. For example, if I had the number 7, I put a 1 over 7, that's the inverse. Now, don't forget that another way to write tangent is sine over cosine. And another way to write cotangent is cosine over sine. So all these things that we talked about, now we're just talking about the inverse, the reciprocal of each one of these. All right. So again, this box, maybe this here, but definitely this box is good for you to have written down in your notes. All right. I'm using this screen because I like some of the information on here. And so that's why I'm using this screen. All right. Given the triangle at the right, express the exact value of the 6 trig functions in relation to theta, this angle right here. And so first thing we need to know is what this side is. And so here we go, using Pythagorean theorem, we figure out a squared, b squared, and c squared here, that this side here is square root of 7. And so now we are able to say the sine of theta here, and this is an example that you probably want to write down. The sine of theta is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. Now, in order to figure these out, it's just a reciprocal. So, here you go. Hypotenuse over opposite. So, it's basically the reciprocal of this, 4 over 7. But we never want to keep a square root of anything in the denominator. And so we do what's called rationalizing the denominator. If you actually put this in one of the yellow calculators, it'll do it for you. I can show you about this in class, but it's something that we need to discuss later. So put any radical in the denominator in your calculator so it can rationalize it for you. The secant is hypotenuse over adjacent, and so we just take the reciprocal of this one here. And again, you take the reciprocal of tangent, you get 3 over square root of 7, and then you have to rationalize the denominator. Okay, so this is just a practice using the I'm going to say inverse, but the reciprocal functions here, showing you that they are the same thing. I like this right here. It says every time you see a 3, 4, don't always assume that it's a 3, 4, 5 right triangle. I don't know if we talked about the Pythagorean triples and things like that. Anyway, notice it says do not estimate the answers. That means we don't want any decimals. So you keep it like this. That's when you want the exact answers. Okay, let's look at these 2 examples. If I give you that the cosine of theta is 12 over 13, find secant of theta. Well, this is easy because secant is simply 1 over cosine, or that means the reciprocal. So basically they show you that if I put 1 over 12 over 13, this is cosine. Cosine of theta is 12 over 13. When you simplify that in your calculator or on your paper, you should get 13 over 12. So again, if I give you the cosine, you ought to be able to tell me what the secant is, and vice versa, because they're reciprocals of one another. Now, find secant theta and cotangent theta if they tell you that the sine is this and the cosine is this. Okay, so what you would do is you would draw a right triangle. Give your angle, one of your acute angles, theta, and the sine is 2 over 3, so you write 2 on the opposite, 3 for the hypotenuse, and the cosine is square root of 5 for the adjacent and 3 for the hypotenuse. So that's how you fill this triangle out. Then you're able to figure out, don't forget what secant and cotangent is. Secant is hypotenuse over adjacent, hypotenuse over adjacent, okay, and then they rationalize. Cotangent is adjacent over opposite. So that's this over this. Adjacent over opposite. So the point is this. If you know the three sides and you know the ratios of sine, cosine, and tangent, what you need to remember is this up here. That cotangent is the reciprocal of tangent, secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. If you remember these are the relationships, these are the only ones you need to remember, because what you'll have to do is just simply take the reciprocal for cosecant of sine, for cosine for secant, and for cotangent you would do the inverse or the reciprocal of tangent. These are what's important, and remember what goes with each one of them. And that's basically how you will work this. If you got questions, ask your mama. I'm just kidding. If you got questions, we'll talk about it in class.